Hey Year 8s, we're going to do this experiment, investigation 8.8 on 327. I've got a worksheet. So this experiment is changing the rate of reaction to investigate the factors that affect the rate of chemical reaction. We're going to look at 3 factors that can change the rate of reaction. The 3 that we're going to look at are changing surface area, changing concentration, and changing temp. Now, part of the observations, if you look at the worksheet I set up for you, you've got general observations, and then the other 2, what we're going to look at is we're going to look at time, how long the reaction went for, and also the height of the bubbles, if we get a fair bit of fizzing and there's a bit of height in those bubbles. Alrighty, so the first one we're going to look at is surface area. So I need a whole piece of chalk, broken chalk, and I'm going to have to crush some chalk. Alright, so I'm going to use a mortar and pestle to crush up that chalk. Now, in a perfect world, I'd have 3 helpers. I do have Professor Bones here, but he's not the best helper. And we would drop the chalk in all at the same time and pressing start on the stopwatch. What I'm going to do though, because it's just me, I'm going to try and be nice and quick. I'm going to start the stopwatch, put each piece of chalk in as quickly as I can. Now, I didn't weigh the chalk. I just did it off size, so they're about 2 centimetres in length. But to improve this experiment, if you actually weighed the chalk and made sure the mass was exactly the same, that would be even better. And can you think of another way that you could make this experiment more reliable? All right, let's go. Let's see how we're going to go. All right, so I'm going to press start. And then going for 35 seconds. Let's have a look. Which one seems to be producing more bubbles out of those 2? This one's already reacted. And I put a mark for the height so that we can measure the height. So that one reacted really, really quickly. So hopefully you were looking at the stopwatch for that reaction. These 2 are still going. Oh, that first test tube looks like it's going pretty slow. Might be a good idea to take your observations from when I first added the chalk in. To make this consistent, if I'm measuring height of other ones, I'm not going to do it from the height of the liquid. Oh, where'd my little black mark go? I'm going to do it from the height of the workbench, okay, because that will be consistent with every single test tube. Can you see that black line? Read it off. It's just below the 10. Can you see the millimetres? And we're going to measure it in centimetres. So what is it? 9 point. So it looks like the reaction has nearly stopped in the second test tube, this one here. There's only a couple of bubbles coming off it now. We've still got quite a few bubbles coming off this one. While that one's still progressing, we're up to 7 minutes and 10 seconds, I've started to set up the next one, which is on concentration. So I've got they're both hydrochloric acid, still got the chalk, same size chalk. This acid is 0.5 molar. This acid is 1 molar. Okay, you can see there's a warning on the labels because hydrochloric acid is corrosive, and if we get it on our skin or on the workbench, we need to wash our hands for about 15 minutes. Soap helps, and also with the workbench, a really wet cloth and some soap if it's a small spill. If it's a big spill, you'd come and ask me. Okay, and the other reason why we wear safety glasses is so that we avoid getting any of that chemical in our eyes, because remember, it's corrosive, so it wouldn't be a really good idea to get hydrochloric acid in your eyes. Now, to do with the concentration, 0.5 is the concentration and 1. Okay, so you got 0.5, so the stronger acid is going to be the 1. It's more concentrated. Okay, I'll press start and then I'll drop the chalk in. It's going to overflow. Before all that disappears, can you read off the height? Remember, it's in centimetres, so use a decimal point. I'll go back down to the bottom so you can see what's going on in the test tubes. Second one, there was a little bit of froth, so I'll put a mark where it got up to and you'll be able to measure that. Because this one stayed in the test tube. Here we go. There you go, it should be at, oh, look at that. 6 point what? And it looks like we're pretty much finished there. So you could probably read the time for the first one now because it's pretty much finished. All right. So that's that experiment done. That was surface area. Bring you back over to the... Things start to be slowing down a little bit, especially in this one. This one sort of seems to be quite slow. This one's still going very fast. This one's going really slow now. This one, it's still got a fair bit of bubbling coming off it. We'll leave that one set up for a bit more. I'll just give him a bit of a shake. You can see every time I give this one a bit of shake, you get a bit more of a froth, so that means that the reaction is happening much more quickly. really slow over here. Still quite a few bubbles coming off this one, not as many on this one. So I reckon we could say that the 1 molar one is finished reacting, and we've still got a little bit going on in our 0.5 molar. It will get that slow though that we'll just have to stop the timer at some point. There is the odd bubble from here, but there's still quite a few bubbles coming off this one. So I've got the hot here, cold there, stopwatch. I'm going to add them both. See how we go. Okay, there's quite a difference there between the two. And once that height starts to decrease, I'll put a mark. Which I think it's already starting to do because it reacted quite quickly. All right. You can see to the point, this one's reacting really, really quickly. You got that cloudiness because there's a lot of bubbles. They're really small and they're quite fast. Over here on this one, still quite clear. Little bit of the bubbles at the top. It's probably 2 millimetre. And then you can see the bubbles coming off that chalk. This chalk is well and truly already started to break down. So what's actually happened is this reacted so quickly that it's starting to slow down now, whereas this one is just still going at the same speed. All right, I reckon we can measure the height of those bubbles. So you're going from the black line. What's that? 5 point what centimetres? 5 point. Then if you want to have a look at this one, because the bubbles are still there. Not many bubbles. Well, the bubbles are starting to increase on this one now because it's a slower reaction. Look at that. They'd probably be about the same height as this one, but it just took a lot longer. I'd say we're done. So this one here would be finished now, and you can take the time. Whereas over here, we're still going. Remember, hot, cold. At this point, the temperature of the acid will have reached room temperature by now. Probably an improvement I could have done is put this test tube in a beaker of hot water so it kept that heat, and I could have put this one in, say, a beaker with some water and ice to keep it cold. So I'm happy to finish that off at this time for both of them because they would have both reached room temperature by now. I will be asking for you to list some improvements to do with accuracy, reliability, the methodology that I used. So any of those little hints I've given you in the video, please take note. So that's it for the experiment. I'll stop it at that. There we go. And for your discussion, you're going to create your own discussion, and then we'll have an evaluation and then a conclusion. Okay? So remember, with your conclusion, use passive voice. So don't personalise, don't write Miss O'Brien. Remember to keep it general, and always put examples in your conclusion. Now, I'm pretty sure you'll be talking about how, increasing temp, surface area and concentration are all going to speed up the rate of a chemical reaction.